Okay, folks, Locke here. It's your head wizard at 8-bit. Right outside the window there's a workman climbing up a ladder, so there may be some background noise. But I wanted to show Rin and other artists at 8-bit how to use the ASCII OGL function. There's this project I've been working on, a little backstory. This project I've been working on for 8-bit called OGLF, OGLF, which is OpenGL Fancy. It's like an OpenGL type toolkit for Fancy, which allows you to do some fancier graphics than was previously available before frame buffers were added. So anyway, this is about the ASCII function. The ASCII function is part of object #388, and this object function allows you to draw pictures in a text editor, then convert them to a bit graph, take the bit graph and program it with color, or draw pictures with a base64 encoded color palette. So let's take a look at that. So first thing you need to do is create a clone or a child of #388. It's better to create a child, but you get different functionality if you clone it outright. You should never create an object that's going to heavily rely on OGLF by cloning it. You should instead use a parent relationship then. You can have it parent off your branch. To make a branch, you simply clone the original #388 object. There's a lot of functions. There's like 480 functions in there that I've written for people. Many of them haven't even been fully exploited yet. So please take a look at them. Anyway. Alright, so the very first thing you do is that, and then once you have that on you, you type +palette/16, and you see the base64 encoded palette. So it's the same as the regular fancy palette, but the color codes, instead of being in decimal, are encoded into base64. This is because the ASCII function of the #388 object uses these base64 encoded color codes to program itself to draw. So I have a demo already started, but I'm just going to start from scratch here and explain that there is a couple of constraints that you have to be aware of when using the the ASCII object function. What you want to do is first of all, there's these special characters: A, B, C, D, E, F, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you're drawing an ASCII picture that you're going to intend to use as a bit graph, what a bit graph is a programmable image that allows you to program each grouping of pixels to a different color, and you group the pixels with a character, a single character. Don't use any of those characters as your bit graph pictures or pixels. So the other constraint is that images must be an even number of columns and rows, and preferably dividing either width or height by 2 results in an even number. So that's the constraint. This just made it a lot easier to implement and faster, so just follow this guideline. So, for instance, 8 is a good size. You can do 6, but 8 is much better. So 6 violates the second rule, but 8 satisfies both rules. So an 8x8 image, 8x8 pixels, would be essentially 4 lines long and 8 columns wide, okay? Or instead of lines, we can say rows. Okay, so an 8x8 pixeled image. However, there's an aspect ratio thing, so maybe 8x16 is better, but we're going to do an 8x8. So you can try different sizes, that you're free to do that. There is an upward limit of about half the screen size, so about 40 by 20 is about the farthest it will go, which translates to 80 by 40, but sometimes these will break. Further experimentation, you will find limits like that. So this is really good for a small graphic. It's not good for a large image. Anyway, So those rules being said, remember that these codes are base 64 numbers. That's why we're not going to use those characters A, B, C, D, E, F, 0, 1 to describe our bit graph. Okay, this is an interim step. And basically the bit graph allows you to program the color of an object. So let's go ahead and create a bit graph. What you want to do is use X or some other character to represent the background or the canvas. And let's go with 1, 2, 3, 4, 5, 6, 7, 8, and then repeat that 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So it's actually 8. Okay, so there's an 8 by 8 image here. Now at the end of each line you're going to add, so the reason why I use Notepad++, and I recommend that you go get Notepad++ if you don't have it, but you can do this in any text editor. You can even do it in your head if you have to, but Notepad++, when you hold down the Alt key, allows you to select a grid or to insert on many lines at once, and this allows you to kind of look at the copy regions and just act more like a painter. Anyway, you've got these capital X's in there. Now, case sensitivity, it's probably you only get X either way, but you don't want to use A, B, C, D, E, F, or 0 through 9. So instead, we're going to use O. Okay, and we're going to draw an X on this image. O, 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 O. Okay, now we have this X form inside that bit graph, and I'll zoom in even a little farther so you can really get a look at what we're doing here. So you've got this X in there, and then if you wanted to give it, say, a shadow, let's use G, because G is after F in the alphabet, and we're going to create a shadow on this X with the G. Okay, so now you've got an X with a shadow. Now all you have to do to convert this into a bit graph is, let's make a copy of it. And with the copy, we're going to add %R to the end of every line. And then we're going to delete the new lines. This can get a little tedious with a larger image, but and I've made them much bigger than this. But okay, so now we've got that all in one line. That is our bit graph. Now we're going to store it on ourselves. We'll call it ampersand bit me equal bit 1, because it's our first one. And then we're just going to paste that. Okay, so I'm going to put that onto me inside of 8-bit. So now I have an attribute of myself that I can recall at will whenever I want to. Now we're going to program this bit graph by replacing the single characters X, G, and O with a 2-character code found in +palette 16. So let's go back here and look at +palette 16. Okay, now you've got all the colors there. We're going to go with A0, CA, and 5E. So let's go ahead and replace that by doing this. Think, open bracket, show this is an alternative to show picture. Think, U, open parentheses, #388 / ASCII, comma, and then U, open parentheses, bit 1, edit, open parentheses, U, open parentheses, bit 1, close comma, and then now we've loaded that in. Now we're going to replace G with 54, O with 82, I don't know, I said different ones before, but whatever, and X with 7E, 5E actually, I think I said. Alright, so then close parentheses, close bracket, okay, and this finishes this. So now I can call this command by putting that into there, and you can see there that it has those colors, 2 browns and a cyan. Let's go ahead and modify that further. Instead of 54, we're going to go with 99. 82 is going to be F1. Now remember that these are not decimals, so it looks like 99, but it's really base 64 99. And you can see that I was able to program that with a different color. Let's go ahead and replace 5E with 52, which is a dark red, or actually 52 is a bright green. And now you can see that, yes, I've changed the background there. I'll change it again. to say 80. Now you can use the base conv function to basically convert a decimal into a base 64 number. So what I would do then is that I can iterate this ASCII display. So I'm going to add a %r at the end so it hits return after each one. And then I'm going to go iter, open paren, lnum, let's see, 10 to 20, comma. And then, let's see, close that, comma, close that. Actually, let's leave that alone. And then in here, there might be a little glitch, but it's no big deal. You can fix it later. We're going to do base conv, okay, and then pound, comma, 64. And I think this should display a bunch of them, 10 of them, with different colors as the background. Let's see. Up. Wait a minute. Help base convert. I've done this before. Oh, yeah. So it's 64 and then comma the value. So what is FF? Oh, 2. So 10 comma 64, which we converted from decimal to 64. So then let's see that one. No, that didn't work either. Hold on there. Must be a reason for this. For color must be an integer between 0 and 255 or a valid color name. Well, that to me says, let me take a look at my Dungeon Master here real quick. Okay, Dungeon Master. As you can see here, we have some of those bits in there, the GGs and the H's. Oh, there's Rin. Okay, so then let's see. It's going to call base convert. Here, let's just try that. Here, we're just going to do this. This was a very complex demo, and that would work if I worked on it a little bit more. But instead of that, I'm just going to do base convert random, rand 10 to 20, comma, I think it's 10 comma 16. It's base 16, not 64. That's why. 10 comma 16. Hold on. And there's messing me up here. There we go. So if I just keep repeating, sometimes it's getting a weird number. I'm not sure why that is, but if I just keep repeating this, it should give me different numbers. I don't know why that one is screwing up, but it's odd that would, because I've done this before and that hasn't happened. But you can see that it's randomly selecting blue actually all the time. Let's see, base convert 1016 random 10 to 200. There we go. So you can kind of see that it's picking random colors there. So you could do like ramping, meaning like getting brighter and getting less bright. You could do whatever. Now, if you don't want to do that, you don't have to use the edit command in there. If you want to kind of see, it uses edit to replace these codes with the colors. If you don't want to do that, you can just create a copy of this and then use your search replace, to replace X with 99. Okay, make sure that in selection is checked. Replace all. And then we're going to replace, now you have to reselect, there's a little bug there, and then G with 78, okay, and then O with, I don't know, F1, I don't know. Okay, so then now we have this, then we add a %R at the end, okay, and we make it all one line. Okay, you copy that line, and then I would just say think, and then open bracket U, open pound 388 / ASCII, comma, paste that, close the parenthesis right on it, and then hit return, and that should, so that's a static version of that. Now you can even use the frame buffer and save picture functions to save that as a pic. so you could save a series or a ramp that way. So you could essentially pre-compute some of these animations. All right, well, thanks a lot. That's a little demo of the ASCII function for the OGLF toolkit. There's a lot of other tools in there for frame buffers. Most of it is documented. If you just examine it for star doc, or star doc star, you'll see a lot of different docs. Take care.